So this isn't advanced, that's why it's not called Kotlin Advanced. It's Kotlin a little bit more than basics. But we'll try to cover a bunch of things. How many of you are using it in production? Just played with it then, right? Okay. Right, so I'll go through a bunch of different things. We'll look at some things around higher order functions, DSLs, how to create DSL, extension functions, generics, how they differ a little bit from Java, inlining, where inlining is useful. We'll look a little bit at coroutines, sequences for lazy evaluation, and a couple of other features that have been brought in 1.1. That's a lot. We'll try and get through them as much as possible. Also, we're running late with sessions a little bit, so I'll try and speed up. Okay, if you have any questions, feel free to just keep them to yourself. Don't ask me. I'm joking. Obviously, interrupt me and ask me anytime. And away we go. So we'll start with the DSL stuff. And if there's, I'll go through some things quite fast. If you do have something that you don't understand, just stop me, right? Because maybe most of the things I'm guessing that you're familiar with. So you're all familiar with the concept of higher order functions, right? Where it's a function that takes a function, or function returns a function. And just to get familiar again with the syntax of Kotlin, so here I declare a function of higher order that takes a parameter of type string, and then it takes another function that takes a string and returns a string. And I'm executing the operation by just calling op and the value that's passed in, right? So here I have the similar, here I just have a lowercase, ignore that. Well, this is a function that matches the signature up here. So it takes a single parameter and returns a string. To call it, I just do higher order hello, and in this case, I'm passing in the function name by reference. Obviously, here I could also pass in a lambda expression, so I could say x plus whatever. I could also just use the it reference. When there's a single parameter in a function, I can just use it and not have to explicitly refer to the parameter when I'm declaring the lambda. Okay, everyone's good with that, right? If I don't hear a no, I will assume everyone's good with that, right? Good. So you don't have to constantly say, yes, Hadi, we're good, move on.
We didn't intend to do it anyhow.
What, are you Swedish? The Swedish people are very, very quiet. Are there any Swedish here? No, very quiet. Only beaten by the Finnish. We're more quiet. Anyway, awesome people, but very quiet in talks. Right, so we've taken these higher order functions. We've got a lot of higher order functions built into the standard library in Kotlin. You've seen some of them like with, which is part of the standard Kotlin that takes a function block with a given receiver as its receiver and returns a result. There's another one that quite often used, which is let, which allows you to use an object inside that scope without having to declare it externally. So a bunch of these are built in. And you can also create your own. So here's an example of me creating a using statement, right? If you're familiar with C#, I have the using, which is kind of similar to try with resources. I do something, and then something that has to be disposable, something that has to be closable. I do something with it and then free the memory, right? So I could create that same kind of structure in Kotlin by creating a top-level function that is a higher-order function that takes a closable object, and then it does something with it, with the code that's being passed in, and then closes that object. Given the fact that Kotlin allows me to have a lambda on multiple lines, it gives it this kind of like little structure in a sense, right? So this really kind of looks like a keyword of the language, but it's not a keyword. It's just a function that I've declared. Okay. Now, with extension functions, one of the key aspects of Kotlin, if you're not familiar, again, very, very simple concept, is I can extend any class, be it a Java class or a Kotlin class, with new functionality. So here I have a string to title case, and what I'm doing is basically extending the class string with a new function, which is to title case, okay? And returning the value. And then you can have, take that, so for example, func string is the same as, for instance, and then I pass in a value here, value string, and then I can say this equals value, right? A single line, you don't need to open the curly braces and all of that. This is referencing the instance of that class, that object that I'm creating an instance of, well, class I'm creating an instance of. So this allows me to do something like this. Hello is the same as hello, right? And you can make this even a little bit more nice and say hello is the same as hello, right? Now that gives you an error, but this is what I call IntelliJ-driven development, which is essentially fix that for me, and it just adds an infix modifier to that function, right? So functions that allow you to have extension functions or member functions that have a single parameter can be called in infix notation by prefixing it with infix. And you can still call it in the same way as you can see up here, okay? Now, I'm showing you all of these because we're going to eventually combine them all. There's another thing that you can do in Kotlin, which is an operator called invoke. In Kotlin, different to Scala, you can't create an operator out of every symbol and its mother. Here you can only create operators, override operators that we define and a series of conventions that we have. So one of them is the invoke operator, which essentially means that I can now create an instance of a class, in this case foo, and then invoke that object, passing in some parameters, okay? Now, all of these are very similar to the concepts that you have in other languages, but one thing that is unique to Kotlin to date is this concept of lambdas with receivers. And we call them lambdas with receivers because we kind of invented them. Some at times they were also called like higher order extension functions, but I think we're settling on the name lambdas with receivers. And essentially, this is a higher order function, as you can see here, right? But what this is a higher order function that doesn't take a normal function, it takes an extension function, okay? So that means that when I pass in this lambda, this is an extension function to root handler, meaning that I have access to everything that the root handler provides me, okay? So you'd say, why do you want to do that? Well, because it looks cool. I'm joking. Here is why you want to do something like that. Okay, scroll this up. Here I have a class request and a class response, right? The request class has a method, property, a query property, and a content type. The response has a contents and a status code, right? Now I have this class root handler that, ignore this, I mean, this is not even relevant to it. I'm just giving you an example that it can have any code there, that takes a request and, has a request property and has a response property. Now I declare a function that's called a root handler that takes an extension function of the root handler class, and then all it does is just return that function, okay? So I can now do something like root handler, and this is a lambda expression, right? If we do root handler, here you see that the IDE gives me the completion directly there. This is what we're expecting. We're expecting here a function, right? In Kotlin, like Groovy, if the last parameter to a function is another function, you can just drop it and go outside, right? But here's the key thing. This isn't an ordinary function. It's an extension function, which means that I have access to all of the properties of that class that I'm extending. So I have request, and then from here I have content type, etc. So why did we do this? This is how you can create those DSLs, right? This is how Cobalt has created a DSL for building. This is how you can create, if you've ever seen the Groovy HTML builders, that's also part of this way of creating DSLs, okay? So it allows you to create nice looking DSLs, and of course I can extend this with other things. I can say, request content type, and then inside the request have a response, and then inside the response have like status code equals 100, right? This one is, that would need to be a var, but this, it says, oh, let me create a member function. You see, you can even do this all without even knowing what you're doing, like me. And go back to where I was, right? So, well, you get the grip. So what I just showed you is it's using that invoke that I just talked about to allow you to combine these and create this kind of DSL flow. Okay? If you look up HTML builders, Kotlin HTML builders, you can see that we have this Kotlin HTML builders. This is the type-safe Groovy builder, so you can see that all of this code here is basically HTML, but it's all statically typed. Each of these are functions, properties of classes, etc. Okay. And as I said, Gradle does this, Cobalt does this. All of these have created different DSLs. There's another project called Tornado FX, which is a wrapper, a DSL around. It's actually not only a DSL, it's like an application framework for JavaFX. So you can create your views using a DSL that Tornado defines, as opposed to using XML or actually declaratively creating all of the different objects. Okay? So you can see that here I have with root, send to the table view, have a field set, a field, etc. And all of this is translating obviously down to JavaFX under the covers, right? It's all interop, so it's just calling, it's not reinventing anything, it's just calling creating all of those JavaFX controls itself. Any questions? No? Nothing. Okay. Are you still following me? No? Nothing. Okay. Do you want to leave? Well, I would say go out early for lunch, but the lunch here isn't that great anyway, so at least it's got it common with so Devox. How many of you have been to Devox Belgium? So you know that it's got fame for not having the best lunches, to the point that they actually create their own videos saying how bad our lunches are at Devox. I'm not saying it, they are. Okay.
No,
so
but they beat all kind of records here, including the...
Yeah. Okay. So inlining. Now, in the higher order functions, when you pass in another function, what's going to happen is that it's going to, it's creating a call stack, right? So you might question, like, how does this impact the performance? You know, what happens here when I have a lot of functions and, you know, I want to, all of these are being passed in and it's creating, if it's targeting Java 6, it's creating anonymous classes, and, you know, this might have performance issue. What you can do is inline some of these higher order functions, right? Inline, which basically means copy paste the code anywhere that function is called, right? And if you look at the standard library, a lot of the functions that are part of the standard library are inlined, okay? So if I come here and I say inline, right? What this is doing is now inlining this. So every time this operation is called, it's going to inline the code along with the function that it is being passed in. Now, of course, this means that every time I do this, it's going to copy paste that code everywhere in my code base, right? Essentially, I mean, once it compiles to bytecode. So you got to, see whether it's worth it. If I'm having very long methods, is it really worth for me to do that? It only makes sense to inline functions that are higher order functions, because otherwise it really doesn't make sense. In fact, if I were to do something like inline here, it would say, expected performance impact of inlining is negligent, it's insignificant, it's of no use. So why would you want to do something like that? Sometimes you have multiple parameters that you're passing in, multiple higher order functions, multiple functions that you're passing in, and maybe at times you don't want to inline a certain call for interop reasons or for whatever, and you have this no inline directive, right? So if I have multiple lambdas, one of them I can say, multiple functions, one of them I can say don't inline that. Now, I've added a no inline here with a single function being passed in, and I've got this inline directive, so again, it's going back to what are you doing, right? You're saying to me to inline, but the only thing that I want to inline is that function. So what's the point of that if you've just told me to not have that no inline? Now this gives way to a bunch of different things that we're going to take a look at. And in particular, returns, which affects the behavior, okay? So let me ask you a question. Here is a function that says containing function, numbers 1 to 100, and it says go through them, and when you find one that's divisible by 5, return. If I run this, what do you think the output of that would be? So if I come here and say containing function, what do you think the output of that would be? 1, 2, 3, 4. Okay, what else? What will it print? Hello or nothing? Nothing. So let's see what it does. We'll run this. And it doesn't print anything. Okay? Who expected it to print print hello? Anyone? Right. That's a non-local return, because what it's actually doing inside the lambda, it's returning outside of the containing function. Okay? Now you can change this behavior. Now let's say this example. Okay? Instead of using for each, I'm going to do my for each. Right? And I'm going to write a print line hello here. What's the result of this? If I were to uncomment this line, what would the result be? Hello? No, compiler error. Right? And that's because return isn't allowed here, because this only works for functions that are inlined. Okay? So if I inline my for each, then it works, because it makes sense, right? It's inlining, and the return is acting on that code that was copy-pasted, and it's going out, right? So what happens when I want to actually print hello? How do I do that, right? What you can do is you can say to return at the lambda. In this case, the lambda is the for each. So I say return at for each. So in this case, what it's doing is a local return. It's coming back outside of this lambda. So when I actually write here return, you can see that completion provides me with the ability to do it at for each, because the function is called for each. If it was called Joe, it would do return at Joe, right? So if we go to containing function 3 and run this, you'll see that it does print hello. Okay? Now you can use the label as the name of the function, or you can even define your own kind of labels, right? So here I'm giving this lambda label, and I'm saying this return point a label, and I'm saying my label, and then I get completion to my label. Okay? Now, yes, go ahead.
Do you see a version of Kotlin that is smart enough to decide on its own whether to inline or not inline?
Now
it is up to the developer to decide.
Yes. Okay, I see. I don't think so. I think that there's reasons behind that it wasn't initially done.
So when you return at my label or at for each, does it go on to iterate 6, 7, 9, or does it?
No, it just comes out. Okay. So it's returning outside of this lambda.
It's a go-to.
Don't say that word.
No, it is.
Don't say that word.
I'm sorry, but it is.
Containing function 5, what do you think that does? Okay, now you're kind of like, why? Let's see what it does. Prints hello. Because this is not a lambda. This is, well, it's a lambda because lambda is an anonymous function, but it's an anonymous function. It's not a lambda, it's an anonymous function. So you can see that there's an actual function here. Okay. So if you don't want to use labels and you want to pass in, you don't want to explicitly call that function, you can just create anonymous functions, which is a different way to create anonymous functions. So that's one aspect that inlining also impacts. The other one is in terms of type erasure. Right? So for those of us that came from the .NET, the JVM is this horrendously horrible place where what do you mean I can't query on my types at runtime? Okay, on my when I have generics and want to see the type. Well, JVM suffers from type erasure. Suffers. It's an architectural choice for the benefits that it has. With Kotlin, we also have to, we inherit that type erasure. But when you have inline functions, you can add the reified to it to then get some information about that type at runtime. Right? So here, I have an inline function. And notice that this is giving me, again, that warning. It's saying there is no expected improvement. Remember I said the only reason you want to do an inlining is because if you're passing in a lambda, I lied. Sometimes you want to do that when you want to use reification. Okay? So here I can't say if input is of type T because it says cannot check for instance of arrays type. However, if I say that this is reified, I can now do that, and that warning also goes away because it understands that the reason that I'm doing this is to try and get information at runtime. Okay. So there are certain cases where you will be able to use this reified to be able to query information at runtime. Here's another type, right? I print line the type, otherwise I wouldn't have that information, and adding reified allows me to get that. Okay? Now, another aspect of Kotlin is delegation. How many of you use delegates in Kotlin? Okay. So delegation is basically essentially you can do delegation of functions. So one class delegates functionality to another class. In a typical scenario, what you're doing is, you've got the concept of dependency injection where you have a class that's passing in another class, and then it's delegating that functionality to that class. We kind of built that in as a first class delegation where you can just say it's the class, the functionality is delegated by some other class, and you don't have to have that private field, which there isn't fields in Kotlin, property, private property to hold an instance of that object, right? Basically composition. But you also have delegation of properties. So I can create some code that I can reuse over and over again in different places and have the implementation a single time and properties using that implementation. So here I have a delegate, and the standard library again ships with a bunch of out-of-the-box delegates, right? There's a lazy delegate. So here you can see that I have a lazy property. So what this is going to do is a lazy evaluation. It will lazily evaluate when the first time that property is accessed. And I'm saying evaluate it using, run the function init late, and this is going to be run. And you can set the threading model here. So this is built in. If you go to lazy, you can see that it uses a synchronization to say if, do you need any kind of locking on it? And this is built in. The other one that's built in, well, there's a bunch built in, but another one that's built in is called vetoable, right? There's an observable one built in that fires off something every time the value changes. And then there's vetoable, which basically says if a certain condition is met, then change the value. If it isn't, don't. So here I have a lambda that the syntax of vetoable is an old property, the name of the property, the old value, the new value. So I say if the new value starts with S, then change it. If not, don't. So if I run this, you can see that string, string, strange. Because it was string, I set it to change. It doesn't start with S, so it still prints out string. I then change it to strange, and then it sets the value, right? So there's a bunch of delegates built in that you can take a look at and see all of the different ones that are built in. Okay, observable, vetoable, not null, etc. Now, I think that's property delegation. If you want to go one step further, you can also create your own delegated properties, right? Not just use the lazy and all of that. And so here I have a class service that has a property delegated property string, and I'm saying delegate that to a custom delegate, right? Now, what this basically means is that I have to create a class. It's not an interface. I have to create a class that implements two operators, get value and set value. Okay, the class has to have this signature. And then here again, I have the property, and I can access the values, the type, the name of the property. And if I need to have a backing field, then I can just create a private property to have that backing field, etc. Okay? So you can use the built-in ones, which probably for the majority of cases works. And if you want something a little bit more advanced, you can just create your own delegated property. Okay, now let's go to, actually, let me leave this one to last. Let's go and see some quick things. So how many of you do Haskell? Right, so you're aware of like type aliases in Haskell. So this is not the same thing. Because you were going to ask, so I'm going to say it's not the same thing. It's not the new type. It's basically it's basically an alias, literally an alias. Like when you go to the command line, what you can do is you can say a type, I'll create a new type, and it's actually an alias for another one. So here I have customer name. So I say customer name is an alias for string, meaning that now when I declare my data classes, I can just say name is a customer name. Right? At runtime, it's a string. When it compiles, it's all a string. It hasn't created any new type. It's just a string. But it does provide you with a little bit more semantic meaning. Right? Because sometimes I just want to reuse the same thing over and over again and give it a better meaning, and I don't have to create a class which is essentially has a property of that value. Right? It's a very simple example of when to use it. Let's go to sequences. So here, if I run this, right, you've all seen things like that in Kotlin, which is an array of numbers, and then I go elements, filter, everything that's lower than 30, and then map that to a pair, for instance. This is going to go through the entire list. Right? It's going to go through the entire list, and it's going to print out the ones that are less than 30. How can I do lazy evaluation? I can just add the as sequence. So now what's going to happen is that it's going to lazily evaluate this. So it's not going to go once it hits that 30. Well, in this case, it will, because it doesn't know that, that it's going to be 31 next or whatever. But it's essentially doing a lazy evaluation from this point on, right? So essentially, a lot of times what you can do is take any collection and then just do as sequence, and then it will convert it. If you want to do something a little bit more complicated, you can just write generate sequence. And then that takes a lambda, and from there, create your own mechanism to do lazy generation, so to speak. Initially, this was called streams, but then Java 8 came out with streams, so we decided to rename it to sequences. Okay. Now, variance and covariance and contravariance and all of that wonderful thing. How many of you are familiar with variance and covariance and contravariance? Okay, so essentially, you've used super, extends, question mark, all of that horrible things. Yes. So Kotlin has covariance and contravariance for generic types. It's different from Java in that in Kotlin it's declaration side, not use side, which makes it a little bit nicer to use because you just declare it once, not every time you use it. Okay. What does that mean? So here, first of all, this is invariant, right? Why doesn't this work? Okay, because I have elements, which is a mutable list of any object, and then I have strings, which is a mutable list of string. And then I say elements equals string. Right? In principle, logically, you would say, well, string is a subtype of any, so in principle, this should work. The problem is that it doesn't, because this is mutable, so you cannot guarantee that you can essentially add a string to it or add an int or add whatever, right? In order to be able to, if it were, then it would be covariance, so to speak, right? But in order to do that, you need to have some sort of guarantee that it is, that I'm only going to be able to like producing or consuming from here. Am I generating, am I reading, am I writing? So in Kotlin, what you can do is this specific one is covariant because it's list. And the difference between list and mutable list is that the list is immutable, right? So in this case, it is immutable. Now, if we go to list, you see that it has the declaration out E, okay? That's what the declaration site variance is about. It's saying that this one is only going to be producing values, right? It's not going to change, so it's fine. In fact, and again, the IDE helps you here, because let's say that I create a class something, which is of type generic. And I go ahead and create a function that says generate something, somethings, and that's going to create a list of T, okay? And just a list of, okay? You see that I get the little squiggly, because it says, well, in principle, this can have out variance, right? Because you're not modifying anything. It's an immutable list, so I can add that. Now, let me go ahead and do fun, like, for example, consume something. And I take a list of T. It no longer offers me that option, right? The opposite of covariance is contravariance, which is represented in Kotlin with in. So instead of out, it's in. And it's saying that, well, this doesn't work, but now that does work, okay, which is consuming. Now, there are cases where you want to be able to declare something as variant or contravariant, but you can't do it as part of the declaration, essentially doing a use site, and Kotlin also does support that. But generally, the way that you work with covariance and contravariance in Kotlin is using the declaration side, which makes it much nicer because every time you use, again, you don't get all of that noise of the super extends. I can't even remember that. I don't write Java, so please excuse my really, really crappy Java. Okay? So, last thing we're going to look at today are coroutines. So how many of you have played with the coroutines? Okay. How many of you are familiar with coroutines? Right. Think of them, very simply put, as lightweight threads. Kind of, right? So let me show you a typical simple coroutine. Now, the idea behind coroutines is, what do we do to bring asynchronous programming to Kotlin? And very early on, Andre and team made the decision that they're not going to build in anything specifically into the language, in the sense that they're not going to do something like what C# did, which was async await, right? So C# has this async await, and then JavaScript has there's a JavaScript library that kind of copies the same concept of async await. So essentially, in C# you would have a function that is async, declared async void or int, blah blah, right? And then when you were calling that, you would say await x equals blah blah, right? Why don't I get completion here? There you go. Huh. Did you know that? You can get text completion. Well, you do because I showed it in my tips and tricks. If that's called hippie completion. If I write B, I get blah blah without that. Right. We don't build that in. So there's multiple options you can use. RX. How many of you use RX? Which is fantastic. Promises, futures, all of these different things. What we did is implement generic coroutines, suspendable computations. And there's actually only a single keyword in Kotlin, which is called suspend. Right? That's the only thing that's been added to Kotlin. All of the other functionality that coroutines provides in Kotlin is actually part of a library. And it's not even part of the standard library. It is part of a library called Kotlin X. So that's why I'm importing here this Kotlin X. Right? So if you come here and say Kotlin X, it's got multiple things. It's got Kotlin X HTML, etc. And one of them is coroutines. Okay? So here what I'm doing is I'm launching coroutines, right? And we'll get to the common pooler and all of that in a minute. And the first thing I'm doing is I'm delaying 1000. seconds. And then I'm going to say print line world, and then continue down here and say print line hello, and thread sleep 2000, right? First, let's get rid of that. And if you rerun this, the result is going to be hello. Why? Because it's launched this coroutine, this lightweight thread, and it's immediately continued from here. It's printed hello. This coroutine didn't have time to complete because it was on a delay of 1000, right? So that's why you only get hello. So in order to actually see the result, I'm going to add that thread sleep at the bottom so that the main thread can sleep so that you can see the result, right? So now you see hello world, okay? Now, this is not the clean. You don't want to be having these things in your code base, right? You're not going to be having thread sleeps in places. The proper way to do this is saying that you're returning a run blocking, or wrapping this in what's called a run blocking. So run blocking is a function that takes some code and then runs that code and is basically waiting until that coroutine finishes and dumps it back on the main thread, right? So essentially what I've done is remove that thread sleep, right? But I've wrapped this in run blocking. So my main is now part of run blocking, and by default, this is returning a unit, which is void, which is nothing. So if I run this, now we'll also see hello world, right? Okay? So that's what the run blocking is, and you're going to see that quite a bit. Now, I told you that this is lightweight threads. Let's do a thread comparison, in fact. Here I have the same kind of thing that we just saw, right, with the coroutines, run blocking. And I'm creating list is a function that takes an integer, a size, and some code, a function that takes that an integer and returns a t. And essentially what this means is that it's going to do this 100,000 times. Okay? By the way, did you know you can do that in Kotlin? I don't like it, but you can if you want. So launch, common pool, delay, 1000, print, and then jobs for each. IT join. Join is like from the same concept of threads. I don't think it's the best name, nor does Roman that wrote this, but he's welcome to suggestions. But it's basically going to wait and then print the result. And I've got the threaded version here, which is jobs 1 to 100,000, jobs for each, create a thread, sleep 1,000, and print. Okay? So let's run this with threads. And we get unable to create native thread, out of memory error. Okay? And then we just get some things printed, not 100,000. Now let's run this with coroutines. Done. Okay? So essentially, it is not the equivalent of a thread as such, right? It's the idea of suspendable computation. I suspend at some point, I do something, and then I come back. So this is, and we'll see what this coming back and where I do this is part of this parameter that we'll see in a second. Now, these are sequential. So if I come here and see these are my suspendable points. So I have suspend first function, suspend second function, right? And what I'm doing here is saying this measure time milliseconds is just the poor man's or layman's version of performance testing, right? When does it start? When does it end, this block of code? So here I have a first function call, and then I have a second function. And I want to print the result of adding those two. And then I'll see how long it took to terminate, to complete, okay? So this is return 13. It's going to delay for 1 second. This is going to delay for 1 second. And it's going to return 29. So you see that it returns 42, and you see that it took 2,000 milliseconds, right? Because it is actually doing it in a sequential order, right? Because these two functions are part of the same running block, it's going to do it in a sequential order. So how do I make this concurrent? How do I make these coroutines be able to run concurrently, so to speak? There's multiple ways, but the first thing that I can do is say async, right? And say run this in an asynchronous way. So don't wait for anything else. Now this goes back to, I just said that we didn't introduce async await. No, we don't introduce those as keywords as part of the language. We introduce those as functions as part of a library. You can create your own coroutine. You can create your own helpers. And we'll see that there's a bunch of different helpers. So this one, if I run, you see that it completes in 1 second, essentially. Right? Now with coroutines, then you can do some fancy stuff. For example, you can cancel coroutines here as well. So I can say job cancel, and that basically what it's going to do is cancel all of those coroutines. And this common pool thing that we've been passing all the time, this is where the kind of like what thread this is acting on. Now, if you're familiar with Rx, you know that you have the observe on or subscribe on, and you can pass in the actual thread, right? Which thread is this? Is this on a worker thread? Is this on a main thread? So you can, in fact, subscribe on a main thread and then observe on a worker thread and then end up in a deadlock. But it gives you that ability. And this is essentially the same thing, right? I can run on different threads. So you have common pool, which is the normal standard one that you use, is just get a common pool from the thread and run on that. Unconfined means that I can run on any thread and I can skip back and forth. Context is on the actual thread that it is. Okay, so it allows you to also have control. But the main key point to take away here is that really the coroutines is nothing more, well, nothing more. I mean, in terms of what it's added to the language is suspend, nothing more. That's the only new keyword. Under the covers, yes, there's a lot more because there's a state machine that's implementing all of this and making, managing all of this, but the rest of it is delegated to a library. By the way, you see that all of these are highlighted with like a little block, right? And that is because it's saying that this feature is experimental. Essentially, and to make this clear, it doesn't mean you shouldn't use this. It means we think we've got it right. But if people start to use it and give feedback and say, you screwed up, we might need to change. But if we change, we'll make sure that we provide you with a migration path, right? So essentially means hit Alt, Enter, and convert it to the new version, right? Which is the same thing that we've been doing throughout the milestone releases. If you're tired of watching these warnings, you can just hit disable coroutine support in current model or enable it, and then that will add something to Gradle, if it actually worked. That would add something to Gradle. Oh, there you go. So it adds a parameter to Gradle. You can add it to Maven. You can add it to IntelliJ build system, everything, and then now it's enabled. It's basically a compiler flag, right? Which is saying that this is highlighting this as experimental or not. And coming down here, you can see that there's the core library of coroutines, right? And then you've got coroutines for JDK, for NIO. If you're doing reactive, RX, there's also helpers to kind of combine the concept of coroutines with RX, right? Because remember, the programming model is somewhat different. RX is always talking about streams, which are observable, and then you're piping the results through different phases. Whereas with coroutines, it's more about, you can go back to that imperative model of programming. But there are times when actually it is necessary or it would be helpful to combine both. Have this pipeline of calls and then get those results from multiple places and combine them in a single one. So you can use the RX utilities here for coroutines to wrap this as like an imperative call. Okay? There's coroutines for Android, which is targeted around Android UI development. There's for JavaFX, just Swing. Roman Elizarov is the guy that's behind this, and the guy's he's amazing. I mean, he really is. Like, he not only does all of the work, he also writes the documentation and the samples. So I don't know when he sleeps. I mean, he's got help as well, but he's really good. Okay, so yeah, those are most of the things that I've shown you here are now available in 1.1. Variance generics has been always available, but type aliases, the coroutines, yeah, those are the two main things that are now available in 1.1. But if you're using 1.0, most of the other stuff that I've shown you is working. Okay. Any questions? Yes.
What's the story on coroutines and JavaScript?
In terms of targeting JavaScript, I believe it's in works still.
But it is in.
Yeah, because the 1.1 release is essentially, we also, like JavaScript was experimental for many years as well, marked as experimental, and it wasn't finished. 1.1, we now made some adjustments, we've cleaned some things up, and we've ported the standard library to JavaScript. But Kotlin X is part of the, it's its own library, so there is no target yet for JavaScript. Okay, well then, thank you for coming. My email, if you want it, is hadi@jetbrains.com, or you can find me on Twitter at @hhariri. And yeah, thank you very much.